So in the previous video we've seen how to write the subroutines, that is a delay program we written. In sometimes if I want to increase the delay, what I can do? So at that time we are going to use the concept of the nested loop. So that means if you want to increase the delay, here delay in the sense it is the maximum value R5 means double FF. Double FF is nothing but it will perform only the 255 times. So that means instead of 255 times, I need to perform more than 255 times. That means double of that 255 times is nothing but we are going to use the concept of the nested loop. So how can I write? Nested is nothing but already you know that in the previous class I explained. Inside for loop, one more for loop we need to write in the C. Like that here also DJ and Z. Inside the DJ and Z I need to write the one more DJ and Z. So how to write here? So this is a move R4 comma 255. 255 loaded to R4. Similarly R5 also I am loading 255 to R5. First time what will happen? DJ and Z decrement for which one? R5. What is the value of the R5? 255. That means 255 minus of 1, 254. Next time after the decrement, now I need to make jump. So condition what is that? After the decrement that value is whether if it is non-zero only. So that means here after the decrement I got 254. But it is not equal to 0. If it is not equal to 0, at that time what will happen? This condition will become. So this is not equal to 0. At the time this condition is true. Then I need to make the jump where the label is again. Where is the again label? This is the label. These are all are the labels. Delay, semicolon. This is also label. Next colon. This also is a label. Again colon. This also labels. So here I written the again. That means again it will come back to the again only. Again it will execute this line only. So next one what will again decrement. So previous value is the 254. So again minus 1. Decrement means minus 1. So again this is 253. So again I need to make the jump when non-zero. So this value is not equal to 0. Again this condition is true. So where should I make jump? It depends on this label. So again it is here. Again it will repeat same thing. But when should it will come out here? Whenever the R5 value, if it is equal to 0. So that means if it is R5 value, if it is becomes equal to 0, at the time what will happen? Jump not 0. But now it is value is 0. So that time this condition is failed. So what will happen? It will go to the next one. Decrement jump not 0. So decrement for which register? R4 register. What is the value of the R4? 255. So now that means 255 minus 1, 254. So now R4 becomes 254. I need to make jump non-zero. So 254 is not equal to 0. Obviously this condition is true. So I need to make jump. Next, where is the next here? Next I written here. So that means again it will switch from this line to this line. So again what will happen? R5 value previously 0. Now it is again loaded to 255. Again it will perform this operation. So that means what you need to understand? R4 value it will perform decrement one time. But R5 value it will perform 255 times. So that means R5 value it perform 255 times here. So R4 value it will decrement by 1. So again it will perform 255 times. Again R4 value becomes decrement by 1. So that means 255. Again double 255 into 255. That is double. So double is nothing but I can say it will increase the delay. Whenever you want to increase the delay, at the time you can write this type of the instructions. So this is the delay function, delay subroutine in order to provide the more a delay in between the switching of the lines here. So this is very important and try to understand. So up to previous one we studied about the L call, that is a long call. So second one more call is that is the A call. A call is the sense absolute call. Absolute call is nothing but we can say it is not that much a longer call. It is the smaller range call. So what is the features here? A call is a 2-byte instruction where you compare to the L call, that is a 3-byte instruction. So out of 3 in L call, first is opcode and remaining 2 bytes are the target address. But in L call, A call what will happen? First byte itself that is the opcode and the next byte it will be the address of the. So this is 2-byte instruction, and one more thing you need to understand, and the memory interfacing we can do up to the 64K bytes. So that means some of the microcontroller they don't have 64K. They may have the 1K ROM or the 1K ROM or maybe the 2K ROM. Is it clear? So at the time what will happen? At the time we are going to use the absolute call. So that means target address of the subroutine. So it should be within the 2K bytes only. So because out of 2K byte is nothing but already in last week we discussed, out of 2 bytes the 11 bits of the we are going to use the addresses. So that is nothing but out of 16 bits we are going to use the 11 bits as the addresses. That means that range within itself is the 2K bytes only. So that means it is not going to cover anywhere within the 64K bytes, because some of the microcontroller they provide the memory interfacing only the internally it have the only the ROM maybe the 1K or 2K. At the time what will happen, if it is a 2K, if you are going to use the LCall is nothing but already know that 2 byte, that is a 16 bit address we are going to use for the target address. But here only by using the 11 bits we can access the target address. That is nothing but if you are going to use the LCall, that is the 5 bits more unnecessarily you are going to waste it if you use the LCall. But in some of within the short of the ROM here, if you use the 11 bits of the address, that is sufficient to access the target address. So that means it depends on the microcontroller internal memory is available. Is it clear? So whenever the internal memory is very small, at the time we are going for the concept of the absolute call. So if somebody is asked what is the difference between the target addresses of the LCall and ACall is nothing but you need to tell like that LCall, that is we can access the target address 64K within the 64K bytes. But by using the ACall we can access the address of the target within only the 2K bytes of the range. So in the LCall that is a 3 byte instruction. So ACall is only the 2 byte instruction. So this is a very small differences between, and sometimes they can also ask it is write the short notes on the ACall and one more is the absolute call LCall. You need to write the differences to this one. Is it clear? And the program wise how to make the difference I can explain with the one example here. So rewrite the previous program. So previous program you return toggling the P1 port by sending the value 55H and the AAH. So how to write or how to minimize this program? So let me start this one. So this is same ORG40H. Last one is the end. In between I am going to write my program. So here also it is say move A comma hash 55H. So 55H I am loading to the accumulator. So again move P1 comma A. What is the value of the content of the A here? 55H itself. So this 55H I am moving to the port P1. So that means 55 is nothing but 0101, 0101. Is it clear? P1 is nothing but already you know that 8 pins are there. So this means I can write this is the P0 0th pin, P1 port, P1 first pin, 0th pin, P1 first pin, second, third pin and so on, 7th pin. So that means this is the individual values pattern. So again ACall delay. ACall delay is the absolute call. So this is the call instruction ACall. Delay itself, this is your the label. So where I written the label, I written the label here. So delay colon. What is this instruction? Again that means this is the explanation also same as the previous LCall also. Is it clear? What will happen here? Execution will be the sequential line by line execution. Whenever this line is occur, so this is your I can say this is the main program. It is subroutine. So whenever this line is occur, at the time it is going to force this as main program. Again it will switch to the delay, so this subroutine. So what it does here, it is similar as the previous one also. What happened here? I am loading the R5 value with the 0FF. Is it clear? So 0FF is nothing but this is the 255. So here what will happen? Again colon DJNZ R5 comma again. So FF in decimal, that is a 255. So what happened next line? Again DJNZ decrement R5. So that is nothing but 255 minus 1, 254. So it becomes the 254. Next I need to make the jump when content of R5 if it is 0, but this is not, it is 0. So you have to make the jump when non-zero. That means condition is true. So where should I make jump? Label again. Again means again it will come back. It will repeat until your R5 becomes equal to 0. Once it R5 equal to 0 at the time, what will happen? It will go to next line RET. RET stands for this is a return. Return in the sense what will happen? It will return from subroutine to the main function. So that means where you follow this here, you follow the main program here. That means again it will switch back to the here. Clear? Again it will go to the next line. What is the next line? CPL. CPL stands for this is a complement for A. Complement the content of A. What is the content of A here? That is 55. So now complement A is nothing but I need to make the bit reverse. That means it becomes the 1010. Wherever 0 you have to make it 1. Wherever 1 you have to make it 0. That means here you got this is A. This is A. Clear? So what happened after the complement of A accumulator, it will change to the double A. So what we are doing here, initially I will send the value 55H. Now I am making the double A by using the complement. So after the complement, I will send SJMP back. SJMP is nothing but short jump. Short jump. This is jump instruction. Where is the label back? Where is the label this one? It is here. Is it clear? So that means this value, it is in the accumulator double A. But I need to update to the port 1. I need to send to the port 1. How can I write? Once it will come back here, again move the content of A to the P1. What is the content of A here? Double A. So this double A, it will move to the P1. Is it clear? So again a call delay. So again it will pause. Again it will come back to here. Again the delay function will perform. Once it complete, again return means again it will come to the this line. CPL A is nothing but complement for double A. So complement of double A in the sense what will happen? Again it will goes to the 55. That means continuously it will switch between 55 to double A to 55. Is it clear? So that means if you compare to the previous same program, so this program is very easier because of I am using the CPL concept. Is it clear? So that means this is the A call delay for concept. Previous one is the L call delay for. Is it clear? And here also it is the same thing. Whenever this line is occur, A call delay is occur. Is it clear? So which instruction is the next one? CPL A. So what is the address of the CPL A is going to store in your the stack. So that means it is going to store in your the stack. So already you know that program counter, it will hold the address of the which line is waiting for execution, next line. So after the call delay, what is the next line? CPL A. So what is this address here? So that address it is going to push to the stack. So what will happen? Again it will switch from this line to this line because of the delay function, called delay function. When it switches here, it will complete this one. Again where should I go for forward line? That is depends on the stack address. So that is nothing but next instruction. This address is already in the stack here. So after completion of this one, it will perform the retrieve or popping of this address. Popping in the sense what will happen? Whatever this address is there in stack, it will pop out to the program counter. Once it popped in the nothing but it retrieve the program counter. That means program counter know that okay, I need to go for this memory addresses instructions execution. So what is this address? It itself or the next line itself. So again it will flow will be get continued. Is it clear? So that means in this today's class they will ask what is meant by the L call and one more is the A call. What is the difference between these two? And give the some of the programming examples. They will ask this one. So you have to write the answer this. This is very important and try to make the practice. Thank you so much.